Hello everyone. Welcome back to Dr. Lou's VCE Chemistry channel. Today, let's learn together about the NHT VCE Chemistry Examination 2022. We will focus on questions related to electrochemistry. This section includes redox reactions, galvanic cells, fuel cells, rechargeable cells, and electrolytic cells. Electrochemistry is one of the most difficult parts, another is spectroscope analysis. My explanations may not be perfect. If any teachers, parents, or classmates find errors, please feel free to provide your guidance. In the list of electrochemical series, the reducing potential of hydrogen ions is higher than that of iron ions. So, hydrogen ions can gain electrons from iron metal. The molecule gaining electrons is defined as an oxidizing agent. So, hydrogen ions are oxidizing agents, and A is correct. To transform between electrical energy and chemical energy, the half cells in electrochemical cells must be separated from each other. So, A is eliminated. Oxidation is defined as losing electrons, and anode is defined as losing electrons no matter how galvanic cells or electrolytic cells are. So, B is eliminated. In any electrochemical, the strongest oxidizing agent should be reduced no matter how galvanic cells or electrolytic cells are. So, C is eliminated. A temperature rise indicates electrical energy is being converted to thermal energy rather than chemical energy. So, D is correct. Ask students to identify a method to reduce the amount of usable energy. This usable energy is produced by the hydrogen fuel cell, so, the usable energy is electrical energy. Supplying oxygen in excess will increase the efficiency of hydrogen fuel cells. So, A is eliminated. Increasing the cathode's porosity will increase the hydrogen fuel cell's efficiency. So, B is eliminated. Reducing the operating temperature of the fuel cell will cause an increase in the proportion of the chemical energy converted to thermal energy rather than usable electrical energy, hence lower cell efficiency. So, C is correct. Reducing the rate at which oxide ions move through the electrolyte will slow down the rate of reaction, but this is unlikely to reduce efficiency. So, D is eliminated. List the order of potentials from lower to highest. X4 plus ions can react with hydrogen gas and X metal. Hydrogen gas and X metal lose their electrons as oxidizing agents here. So, the pair of X4 plus / X2 plus has the highest potential here, and both A and B are eliminated first. Since bubbles of gas are observed when a 1m solution of hydrogen ions is added to X metal, and hydrogen ions gain electrons from X metal as oxidizing agents, hydrogen ions are stronger oxidizing agents than X ions. So, C is eliminated and D is correct. Hydrogen gas and hydrogen ions are different substances. Hydrogen gas is a reducing agent and hydrogen ion is the oxidizing agent. This situation is the same as X ions and X metals. Hydrogen fluoride is a molecular gas at SLC, so its melting temperature is too slow, not too high. So, C and D are eliminated. Fluorine gas is the strongest oxidizing agent. On the other hand, fluorine ions are the weakest reducing agent. If an aqueous solution of hydrogen fluorine is electrolyzed, the water would be reduced, and oxygen gas produced instead of fluorine gas. So, B is eliminated and A is correct. There are two cells. The M-N electrode of cell 2 pumps electrons into the Ni electrode of cell 1, then these electrons are pumped back to cell 2 by the copper electrodes of cell 1. So, the color of the copper nitrate solution will deepen in cell 1 because the copper electrodes lose electrons and produce blue copper ions in the solution. So, A is correct. In this process, cell 2 transforms chemical energy into electrical energy. So, B is incorrect. Although copper metal is produced in cell 2, this electrode is positive because it gains electrons. A negative electrode cannot gain electrons. So, C is incorrect. Although metals are deposited at the cathode in both cells, their mass is not identical because the molar masses of nickel and copper are different from each other. The concentrated sodium chloride solution is electrolyzed here. Chlorine ions should be oxidized instead of water, and chlorine gas should be produced on the anode. So, the electrode X is the anode. Chlorine ions have a negative charge. When chlorine ions are decreased in electrode X, anions are in relative shortage and cations relative surplus on the anode. Surplus cations such as sodium ions should leave the anode and relocate to the cathode to balance the charges. Since the concentrated sodium chloride solution is electrolyzed here, concentrated sodium ions are a stronger reducing agent than water. The chloride ions will oxidize to chlorine gas instead of the water oxidized. The electrochemical series just predicts redox reactions under standard conditions. Calculate the mass of chlorine gas step by step. Students must write the 3 steps clearly. To get full marks, students should write the correct significant figure. This rearrangeable cell contains sodium and sulfur, and solid electrolyte beta alumina is utilized as an electrolyte and selectively conducts sodium ions. In the fully charged cell, sodium metal is inside, and liquid sulfur is outside. When this cell is charging, sodium metal loses electrons to produce sodium ions, cations, inside, and sulfur gains electrons to produce sulfur ions, anions, outside. Cations are surplus inside and anion outside should attract these cations. So, the arrow in box D should direct down, not up. However, the official answer is up. Just write the 2 features of the NHT cell because of 2 marks. 2 of the responses are okay: reversible, portable, 2 separated half cells, anode/cathode, or an electrolyte. I prefer reversible and portable because this cell is suitable for vehicles. When this NHT cell is discharging, sulfur gains electrons. To provide electrons, sodium should lose electrons on another electrode. When this cell is discharging, sodium trisulfide is synthesized. The reaction of charging reserves the discharging, so sodium trisulfide is decomposed when the cell is discharging. Identify and explain one factor that may affect the useful life of rechargeable cells. 1 mark is awarded for features in another explanation. The recharging process does not reserve charging 100%. The textbook lists 5 factors: loss of active materials, larger crystals, impurities in cell materials, decreased contact of electrolytes with electrodes, and corrosion or failure of internal components. One of these factors is suitable for the answer. To use the NHT cell safely, the system must be protected from water. Ask students to explain why, and the explanation should include any equations. Sodium metal is a strong reductant and can be oxidized by water to produce hydrogen gas. Hydrogen gas is highly flammable, and cells will be explosive. There were 6 multiple-choice questions worth 1 point each, totaling 6 marks. There were also 2 short-answer questions worth a total of 18 marks in electrochemistry. The overall score for this section is 24 points. With a total possible score of 120 points, the percentage for this section was 20.0% of the total score. If you need my help, please add me on WeChat or WhatsApp, and send me an email. Thanks for your attention. Please note Dr. Lou's VCE Chemistry channel.